calculate the gradient of the graph for each of these intervals. Now we can see anyway that the gradient is constant for this velocity time graph. So there is only one gradient, so we know that the answer to A and B is going to be the same, but let's do it anyway. Gradient is equal to rise over run, in this case delta V over delta T. V final minus V initial over T final minus T initial. For this whole interval, 0 to 4 seconds, V final is 40 meters per second, V initial 0 meters per second. So the rise is 40 meters per second. T final is 4 seconds, T initial 0 seconds, so the run is 4 minus 0, 4 seconds. 40 meters per second divided by 4 seconds equals 10 meters per second squared. The gradient of a velocity time graph tells us the acceleration of the motion, and indeed we know that the acceleration of this motion is 10 meters per second squared. Now let's get the gradient for the interval 2 to 3 seconds. Gradient equals rise over run, delta V for a velocity time graph over delta T. V final minus V initial over T final minus T initial. For this interval, V final is 30 meters per second, V initial 20 meters per second, T final 3 seconds, T initial 2 seconds. So we have the rise 30 minus 20, 10 meters per second, and the run 3 minus 2, 1 seconds. So the gradient is 10 meters per second divided by 1 second, 10 meters per second squared. The gradient of a velocity time graph tells us acceleration, and indeed the acceleration of this motion is 10 meters per second squared. Let's calculate the acceleration for each of these intervals using the equation of motion. Acceleration equals change in velocity over time interval. Delta V over delta T. V final minus V initial over T final minus T initial. First we define our interval as given by the question. From 0 to 4 seconds. So at the end of this interval, final velocity was 40 meters per second. At the start of the interval, the initial velocity was 0 meters per second. Time final, 4 seconds. Time initial, 0 seconds. So the change in velocity was 40 minus 0, 40 meters per second. The duration of time was 4 minus 0, 4 seconds. So delta V over delta T is 40 meters per second over 4 seconds, 10 meters per second squared. And we know indeed that is the acceleration for this motion. Let's get the acceleration for the interval 2 to 3 seconds. Acceleration equals delta V over delta T. V final minus V initial over T final minus T initial. For this interval, V final is 30 meters per second and V initial 20 meters per second. T final 3 seconds, T initial 2 seconds. 30 minus 20 is 10 meters per second. 3 minus 2 is 1 seconds. So the acceleration is 10 meters per second per 1 second, 10 meters per second squared, which we know is the truth. For this free fall motion, the acceleration is acceleration due to gravity, 10 meters per second squared.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!